Alright, solving by completing the square. Here the main goal is to get it in a place where you can solve by square root method. So for the first example, let's do x squared minus 10x plus 25, which already has a perfect square in it, but we're going to use it for the sake of example. So the whole goal of this is to get it as a perfect square. So you're going to always want to move your last value over to the other side of the equal sign. So negative 25 goes over here, since negative 25 cancels it out over here, and they're going to want to do the same thing to the other side of the equation. And now that you have it moved over, you're going to find how to make it a perfect square. In this case, it's not super helpful, but you're going to find it when you're doing completing the square. So to do that, you're going to divide the b term in a standard form equation by 2, and in this case you'll get negative 5, and then you're going to square that, so you get 25. And then I'll write that over here. Just so it's easier to remember. Okay, so now that you have this number here, you are going to want to put it on both sides, so that on this side you have your perfect square, and on the other side it's balancing out the equation, because you always want to do the same thing to both sides. Alright, so now you can put it in the form of a perfect square, since we got it to that point. So x minus 5 squared is equal to, and then you simplify this, and that just gets you 0 in this case. Alright. And now I'm going to write it up here so it's easier to see. And you're going to want to cancel out that too. That squared with the square root on both sides. So you get x minus 5. Then when you simplify the square root of 0, you just get 0. But I'm going to put positive negative in front of it just so it shows that we get two answers. So x equals 0 minus 5, and x equals 0 minus 5. So our answer is just x equals negative 5, negative 5. Alright. And I'll show you why you don't want to typically do it when there's a coefficient in front in a minute. But typically it is just used for when it's not factorable, and it is fairly easy to complete a square. Okay, for this next one, I have x squared plus 6x minus 7. So again, we're going to want to rewrite it with negative 7 on the other side. So to cancel it out, not plus 8, plus 7 on both sides, and you get positive 7 over here. Alright. And then you are going to want to divide that middle number by 2, and you get 3. Then you square that, and you will get 9. And again, b divided by 2 squared. That's what you're trying to do here. So now you have your perfect square when you write that 9 on both sides. Because you always want to do the same thing on both sides. And then I'm going to highlight it here. Alright, so because 3 times 3 gets you 9, and 3 plus 3 gets you 6, your perfect square is x plus 3 squared. And that's the other way to write this. So that now when we add the other side and get 16, we can use the square root method and just do the inverse of squared. So take the square root of it on both sides. Make sure that you remember that that will give you two answers. So x plus 3 equals positive or negative 4 when you simplify it out. Alright, and now you can write this as two equations if you would like. But x equals negative 3 plus or minus 4. I'm going to just solve it out from here. So, final answer is x equals negative 3 plus 4, which is 1, and negative 3 minus 4, which is negative 7. Alright, now to the last one that makes this a more complicated way to solve it out most of the time. Because if there's a coefficient, it's just going to make it more work than it's worth typically. Alright, so this next example I'll use is 3x squared plus 6x plus 27. Alright, and because there's a coefficient out here, you're going to want to divide everything by 3. So, x squared plus 2x plus 27. Alright. Not 27. I'm sorry. I'm really sorry. Plus 9. Because divided by 3. Alright. So again, you're going to want to move that last term over to the other side of the equal sign. And you're going to want to find what number you're going to put into there. Just draw a little arrow for some reason. Okay. So 2 divided by 2 is 1, and 1 squared is 1. So x squared plus 2x plus 1 equals negative 9 plus 1. Now, 1 times 1 is 1, and 1 plus 1 is 2. So, x squared plus 1, sorry, not x squared, but x plus 1 squared equals, add these, negative 8. Alright, so when take the square root of each side, negative 8 doesn't have a perfect square root. So, like this with when doing square root method, you're going to want to be able to simplify over here. So, positive, negative, and 8 divided by 4 equals 2. So, since 4 is a perfect square root, it simplifies the 2. So we can have 2, and because there's a negative in there, I times 2. And that works because square root of negative 1 times square root of 2 times square root of 4 is the same thing as square root of negative 8. And then you just simplify each piece. Okay. And here, just going to want to simplify and isolate the x over here. So bring 1 over here, plus or minus 2I square root 2. Alright, so your answer can either be left at this, or you could break it up into -1 plus 2I square root 2 and -1 minus 2I square root 2. And that's it for completing the square.